Hello, my favorite chemistry people. Today we're going to be working through some of the Module 11 extra practice problems, and we're going to get started with number 2. So in the back of your book you have these extra practice problems. I'm on page 579, and number 2 says the following reaction is performed in a lab. I wrote it up here on the whiteboard. 3K2CO3, that's potassium carbonate, plus 2AlNO33, that's aluminum nitrate, yields Al2CO33, that's aluminum carbonate, plus 6KNO3, that would be potassium nitrate. If 191 milliliters of 1.25 molar aluminum nitrate, so we're talking about this, so we know how many milliliters, and we know its molarity. If that is used and added to an excess of potassium carbonate, so we have plenty of this, we don't have to worry about this, all right? We're starting with a certain amount of this. How many grams of aluminum carbonate will be produced? So we want to know how many grams of aluminum carbonate will be produced. Okay, let's start by writing out a little map for ourselves, what we're going to do here. We are going to begin with moles of aluminum nitrate, AlNO33, and then we are going to, using the balanced equation, we're going to figure out how many moles of aluminum carbonate we have, moles of Al2CO3, and then the problem asks us for how many grams of aluminum carbonate. So then we're going to convert from moles of aluminum carbonate to grams of aluminum carbonate. Okay, so that's our plan. So we're starting out with how many moles of aluminum nitrate. The problem does not tell us how many moles, but it does tell us the molarity we have and the volume, or the number of liters that we have. And remember, molarity equals moles per liter. So now I want to rearrange this formula and solve for moles, because that's what I need to figure out right now. So moles would be equal to, if I work my algebra magic here, I multiply both sides by number of liters, and then I find out that moles is equal to the molarity times the number of liters. All right, so that's how I'm going to find moles of aluminum nitrate. Moles of aluminum nitrate equals its molarity, which the problem tells me is 1.25, so 1.25 molar. And then in the problem it tells me that I have 191 milliliters. Hopefully you can now convert that to liters in your head. When you're going from milliliters to liters, you just move the decimal place over to the left 3 places. So this would be 0.191 liters. Make sure I have my numbers right. Yep. Okay, so if you plug that into your calculator, my calculator is serving as my video recorder right now, my phone. So you can trust me that I have worked it out. And 191 times 1.25 would equal, oh right, I have to look at my paper. Okay, it's right here. Would equal 0.239 moles of AlNO33. Right, so now I'm here at my first step. Now I want to go from moles of aluminum nitrate to the substance that we're actually trying to find in the problem, which is aluminum carbonate. So how do I do that? Well, I start with my moles of aluminum nitrate, 0.239 moles of AlNO33, and then I'm going to use my balanced equation, because my balanced equation tells me the ratio. If I have this many moles, this is when I look at my coefficients up front. For every 2 moles of aluminum nitrate that I start with, I will produce, there's an invisible one there. I will produce 1 mole of aluminum carbonate. So I'm going to multiply times that ratio. I want my moles of aluminum nitrate to cancel out, which means I need to put moles of aluminum nitrate on the bottom and moles of what I'm going to, which is moles of Al2CO3 on the top. Now that I have my units lined up, I'm going to plug in the numbers. So I said for every 2 moles of aluminum nitrate, so 2 goes on the bottom, there will be 1 mole of aluminum carbonate produced. So the 1 goes on the top. So I'm going to put it in my calculator as 0.239 divided by 2, and I will end up with 0.120 moles of aluminum carbonate. All right, so now we have successfully moved to our second step. Now we know how many moles of aluminum carbonate will be produced. But the question, of course, wants to take it a step farther and wants to know how many grams of this substance will be produced. So now we are going to convert moles, 0.120 moles of Al2CO3, and we're going to convert that to grams of aluminum carbonate. All right, so moles of aluminum carbonate will go on the bottom, and grams of aluminum carbonate will go on the top. Now, do you remember, where can we look to know how much 1 mole of aluminum carbonate weighs, or what its mass is? How many grams is 1 mole of it? That's right, we look to our beloved table and we find the masses for each of the individual atoms. So I will prop this open here. Looking at our formula for aluminum carbonate, how many aluminums are present? You got it, 2. There are 2 aluminums, and each of them weighs 27.0 grams if you have a mole of them. So we're going to have to take that times 2. Next we have carbon. How many carbons are present? Carbon is inside the parentheses. After the parentheses is the little subscript 3, which means everything inside the parentheses there are 3 of. So there are 3 carbons. So to find out how much the carbon would weigh, we would take carbon is 12.0 grams times 3. And then lastly, we have oxygen. How many oxygens are there? Well, inside the parentheses, there's 3 oxygens, but then there's 3 of those 3. Of means times in math. So 3 times 3 is 9. So there's 9 oxygens. Oxygens each weigh 16. So we're going to have to take 16 times 9. All right, so in your calculator, you would do 27 times 2 plus 12 times 3 plus 16 times 9, and you would figure out that 1 mole of aluminum carbonate would weigh 213.0 grams. I'm trying to talk at the same time, and I'm looking at the wrong paper. Don't look at that. I think I gave you the wrong number. I'm very sorry. Yes, I did give you the wrong number. Okay, so not 213. 1 mole of aluminum carbonate would weigh 234.0 grams. All right, so using that information, for every 1 mole of aluminum carbonate, there are 234 grams. Check my numbers here because I feel like I'm talking a little fast. All right, yes, that's correct. So we're going to do 0.120 times 234, and we will end up with 28.1. Our moles of aluminum carbonate are canceling out, so we are ending in grams of aluminum carbonate, which is what the question wanted. which means we are done with number 2. All right, so that's how you do the stoichiometry problem of number 2. Let's do number 3. Erase this.